You've probably seen images of Saturn's rings. They're broad and flat and kind of look like a disk if you squint. But our view of Uranus's rings is very different. In photos, they look sharp-edged and narrow, like the spokes of a wheel, or the grooves on a vinyl record. So what's going on here? Why don't Uranus's rings look like Saturn's? Well, it has to do with what's happening on the edges. Uranus and Saturn both have lots of rings, though astronomers only officially confirmed the ones around Uranus in the 1970s after Voyager flew by. Saturn has more than a dozen known rings, but Uranus has at least a dozen major rings with many more smaller ones, and these rings are intermediate in complexity. The rings of Jupiter are much simpler. They're opaque and only a few miles wide, and the rings of Neptune are more complex. They have fine details and structures that scientists haven't been able to explain yet. Now, even though Uranus and Saturn's rings are intermediate in complexity, they are very different from each other. Saturn's rings are opaque and pretty wide, while Uranus's are narrow and well sharp. To be clear, the edges of Uranus's rings aren't actually sharp. It just looks that way because these rings are opaque. We can't see through them, not because they're perfectly smooth. In fact, they're pretty rough, and scientists have found a lot of small features within them. Take a closer look at this image of Uranus's rings taken by Voyager 2. There's a ton going on here. You can see the step-like features called ring arcs and strange dark spots and streaks. Some of these are opaque like the rings of Jupiter. Others look more like the rings of Saturn. But no matter how closely scientists looked, they couldn't explain the origin of any of these structures, which led them to believe something was missing, like some sort of edge effect. And when they say edge effect, they don't mean the effect of living near the edge of an array. They mean the effect that happens right at the edge of a material as it interacts with its surroundings. Take magnetic fields, for example. When a magnetic material reaches the edge of a surface, its magnetic field lines spread out and weaken. That SYA magnet does unstick to a ferromagnetic material unless it's strong enough to overcome that weakened field. If you want to learn more about magnetic fields, check out the first link in the description. But for now, let's go back to Uranus's rings. Scientists think there must be some sort of edge effect happening there too. But instead of magnetic fields weakening at the edge, something must be keeping the rings narrow. For example, there could be some sort of force pushing particles away from the edges. Or maybe there are unseen forces pulling them in. To figure out what's going on, scientists looked at simulations of how rings form. One of the most popular models is called the linear instability model. It's based on how Saturn's rings formed from a swarm of small icy bodies called planetesimals. As the planetesimals came together, they flattened into a thin disk, because gravity pulls things towards the center of mass. Then over time, the disk became wider, forming rings. Using computer simulations, scientists could tweak the variables to get rings that looked a lot like the ones around Uranus. For instance, in simulations, you can change the size and shape of the particles, how fast they move, and the strength of the gravitational pull. Each simulation produced different-looking rings. And after a bunch of trial and error, scientists found a combination of variables that produced rings similar to the ones around Uranus. They discovered that Uranus's rings could be the result of a swarm of small bodies being shepherded together by one or more moons. But exactly how does shepherding work? Well, if you've ever walked next to another person in a big group, you know that people tend to naturally drift apart. But sometimes you find yourself bumping into the same person over and over again, and then you realize you're walking together in a sort of pair. A shepherd moon does something similar. As the moon orbits Uranus, its gravity tugs on the ring particles, aligning them into a narrow band. But the moon isn't the whole story. This simulation shows two moons orbiting Uranus. Even though the moons orbit at different distances, they both have a gravitational influence on the rings. Where their gravitational influences overlap is where the rings are. The moon's gravity aligns the particles and their gravitational influence confines them. These zones are called Roche limits. Every object in space has one. And if you're wondering how big a moon needs to be to confine a ring, it depends on the particle size. Particles in the rings of Uranus are relatively large. They range from millimeters to hundreds of meters across. And since they're so big, it would take a moon about 13 times the mass of Earth to shepherd them. Luckily for humans, no such moon exists around Uranus or Saturn. And according to our current theories, no moon bigger than 10 or 20 Earth masses could exist out there. So we still need to explain why Uranus's rings are narrow and sharp-edged. After all, we should see the shepherds if they're real. Right now, scientists don't know the answer. Some think the shepherds might actually be smaller than a traditional moon. They might be clumps of ice called moonlets that formed early in the solar system's history. Moonlets are loosely bound groups of rocky and icy bodies that were never quite big enough to become moons. Scientists think moonlets are basically the building blocks of planetary systems. There are thought to be millions of them in the asteroid belt between Mars and Jupiter. But detecting a moonlet is really hard. You can't see it easily with a telescope. And if it isn't emitting light, there's no way to tell what it's made of. Plus, because they're so small, their gravitational pull is weak, which makes them hard to track. In fact, some scientists think the reason we have undetected Uranus's moonlets is that they recovered in a layer of ice. Underneath that ice, the moonlets have a rocky mantle and a metallic core. Scientists used to think that ice played no role in planetary formation. They believed that in systems like ours, everything started out hot enough to melt ice, and it stayed that way until the planet cooled off. But that left scientists with an ice problem. Ice doesn't preserve on planets like Earth, Venus and Mars. It's possible that the ice either never existed or else it got baked away early in the planet's history. But scientists think the ice might have condensed on objects like moonlets. If that's true, then a Uranian moonlet could look like a big ball of ice. But without a spacecraft close enough to detect its gravitational pull, there's no way to prove that it's a moonlet. For now, scientists will continue to hunt for the mysterious shepherds of Uranus. In the meantime, though they have a new mystery on their hands, the images from Voyager also revealed something weird about Saturn's rings. In the 40 years since those images were taken, scientists have noticed that the rings look different. They've gotten brighter, and some of them seem to be getting wider. And to make things even weirder, the changes seem to happen at random. If you want to know what's up with Saturn's rings, you'll have to check out our video on that. Thanks for watching.